Hi everyone, welcome back to the channel, and today on Solve Leetcode Daily Challenge, problem number 1481, least number of unique integers after k removals. So it is tagged as a medium problem and it is an interesting problem to solve. So we'll first check out the problem statement, then we'll look into the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that we'll get a array of integers ARR and another integer k, and we have to find the least number of unique integers after removing exactly k elements. So for like they have given these examples as well. For example, we have two um, we have three elements in an array 554 and k is 1. So if you remove 4 from this, because you have to remove only one element, so if you remove 4 you will end up with just one unique element, that will be 5, right? Similarly over here, like they have quite a few elements and number of elements allowed to be removed is 3, so you can remove uh, all the elements which are occurring least number of time first. For example, we have 4 occurring ones, then 2 occurring ones, then you can remove either from 3 and 1, the result will be same, because you will have 1 and 3 as two unique elements, so that's why answer is 2. So as I said, like what we will be doing, we'll be removing the numbers with least frequency first. And when I said this, and when I was solving this question, the first approach which came to my head was using a heap. Okay, so what I'm gonna do, so this is the exact same problem which was given in the problem statement and the same value of k. I have calculated the frequency of each element in this hash map. Okay, and after that, as you can see, like we have two ones, three threes, 1 2 and 1 4. So this is the frequency plot of the given array. Now I'll take the values from it. By value I mean all the frequencies. Okay, all these frequencies, and I'll plot a min heap from that. So this is a min heap. Min heap is like heap is nothing but a balanced structure, which, if you traverse this, you will get a sorted list kind of a structure. Okay, so this is a heap generated from the values, the frequency values, and this is I'll be using additional variable called removed. So this will basically represent the unique elements which I have removed. And if you try to think hard, so each node over here represents one unique element in the array. Okay, so this can be 4, or this can be 2, this is 3, this is what, 1, right? We can assume this. Okay, now at k equals to 1, what I will be doing is I'll be removing or popping out elements from this heap k number of times. So let's say we have k equals to 1. Okay, now this heap will end up look like this 1 3 and 2. Okay, so we have removed 1 from it, and that value, that 1, I'll add here. Okay, so now the value of removed is 1. Okay, now we are at k equals to 2. Again I will remove the smallest possible value, so which was 1. So we'll get this kind of a structure, and the value which we removed will again be added in the removed variable. So now k is equals to 2. Okay, now again, we will try to remove k equals to, for k equals to 3. Okay, but if you see, this time we remove 3, this time we remove 2, sorry. Okay, and we are only left with 3 now. But if you add 2 in this, in your value of removed, it's gonna end up being 4. Okay, and 4 is greater than k. So removed basically represents the number of unique elements I have removed yet. Okay, and we already know that we can at most remove k elements. So this is the point where I would like to break the loop, and I will just say that okay, now the solution basically is the number of elements left in the mean heap plus 1. Why? Because I cannot remove 4 elements from I cannot remove number of elements greater than k from the array. Otherwise, like there can be chances. For example, if let's say k was what 5 7, if k was 7, then we can remove all the points and our answer will be 0. Answer will be 0. So this is the overall approach which you're going to use. Let's check out the code as well. So this is the code I was able to come up with. So first we calculate the frequency of each element. After that I got the frequency values using dot value method. And what we are doing after that, we are converting that frequency into the heap. Okay. Now comes the remove variable which we discussed in the explanation. And while frequency, like while I have the variable, what I'm doing, I am basically popping out elements from the heap, okay, until the number of elements removed is greater than k. Okay, so I know that okay, now I have already removed numbers greater than k, and it is not possible to do that. So now what I'll do, I'll just simply return the number of elements left in the heap plus 1, because of course you cannot remove more elements from k. And if by any chance, like we remove all the elements from the all the from the heap, then in that case I'll be returning 0. Let's check out the test cases. And the test cases got clear. Let's submit for further evaluation. And as you can see, the solution got accepted, and like I would say, we have performed fairly well on both the fronts, on runtime and memory. So yeah, this was the solution, guys. Thanks again for watching out the video. Stay tuned with the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.